Okay, guys and girls, I'm on page 3 of your packet now. These two terms up at the top, I would say the rest of this page you've probably heard of, but these two terms up at the top, I would be shocked if you've actually heard these terms before because this is a pretty new concept for 6th graders. You can see here that we've got a polygon. It's closed. It's made up of line segments. Even though it's a plus sign, it's still considered a polygon because it's a closed figure with line segments. So here is one of the ways you can classify this as well. If you notice, I just chose this interior point and this interior point. And if I join those 2 points, I would actually cut through an edge of that polygon. If that's possible to do. Now, obviously, you could take these two and it wouldn't cut, but if it's possible, in other words, if I use this interior point and this interior point, if I join those and I would cut the edge of that polygon, what that's called in geometry, that shape is considered concave. And a way to remember it, just think about a piece of the shape is missing. So concave, for example, if you had this shape, and again, this is considered a polygon. It's a closed figure with line segments. Now, if I chose those two, no, you're not going to pass through an edge. However, if it's possible to join 2 interior points and cut through an edge, that's called concave or concavity. You're going to hear both ways. So concave can cut through an edge, but if you've got a shape that looks like this, that I don't care which 2 points you choose on the interior, you're never going to cut through an edge or a side if it's not possible. This is called convex. So you've got concave and convex. Concave looks like a piece that's missing. Convex, nothing's missing. So that's two new ways that we can classify a polygon, whether they're concave or convex. Now what we're going to start doing is we're going to start talking about ways to classify a polygon according to the number of sides that they have. And I'd say most of you have heard of this one before. If you're a 3-sided polygon, you're called a triangle. Now, triangles are weird. We're going to have a whole unit on triangles when we start talking about Pythagorean's theorem and some other things. Triangles have their own special little set of geometry, especially the trigonomic ratio, sine, cosine, tangent. That's high school stuff, but triangles are pretty special when you get to geometry. We're going to simplify it. All we're going to do is classify triangles according to a first name and last name. The first name of a triangle is going to be according to the side lengths, whether they're congruent or not. If you look at a regular triangle, in other words, this is a triangle where all 3 of these sides have equal measure, it's regular. What this is called an equilateral triangle. Lateral in Latin means side, equa means equal, so equal sides, that's where that word comes from. So equilateral means all sides are congruent. Well, if you look at this second triangle, it looks like these 2 sides are congruent, but not the base of that triangle. So this one, we only have 2 sides congruent. It's a weird word. It doesn't sound like it actually looks on paper. I'll write it down first. The word is isosceles, and an easy way to remember it is look outside your window in the fall and go, hey, look, I saw some leaves. I saw some leaves. That's how I remember it, the word isosceles. It's not isosceles, it's isosceles. Iso means 2. Sides are congruent. When no
sides are congruent, all 3 are different lengths. This is something in math called scaling. So these 3 ways to name a triangle are according to the sides. Equilateral, all 3 are the same. Isosceles, 2 are the same. And scalene, none of the sides are the same. Then, for a second name of a triangle, just like you have a first name and a last name, you can name a triangle in 2 different ways, by the sides and now by the angles. And these are terms we've already covered in the first part of geometry. If you have, yes, all 3 sides, but that's not what I'm looking at now. I'm looking at the angles. If you knew that all 3 of these angles inside this triangle were less than 90 degrees, this is called an acute triangle. So if you were to name this in 2 ways, this would be an equilateral acute triangle.
equilateral, all three sides are the same. Acute, all angles are less than 90. So you would name it in two ways. Then you have this triangle where if you notice this angle right here on the interior, that angle right there is actually greater than 90. 90 degrees would be about right there. So if the angle goes behind 90 degrees or greater than 90, we already know this word. This is called an obtuse triangle. So an obtuse triangle is going to have one angle that's more than 90, acute, all are less than 90, and then you have this triangle right here, which has got one 90-degree angle. So basically, if you cut a square or a rectangle by its diagonal, you cut that in half, you've created a right triangle. What this is called a right triangle. And basically, it's a triangle with exactly one 90-degree angle. Now, again, you can name these in two ways. This would be a scalene right triangle. This would be a scalene obtuse triangle. And this would be an equilateral acute. Now, if you had something like this, like a skateboard ramp or a mountain, and you knew that these two sides were congruent, and you knew that this angle measure right here was 120 degrees, this would be considered an isosceles obtuse triangle. And just like this, if you knew that these two sides were congruent, what this would be called would be an isosceles right triangle. So again, you could name a triangle in two ways, by its sides and by its angles.